Hello, this is Mr. Jarrett, and in this video tutorial we are going to be 3D modeling all of the parts for this wall shelf and assembling them in SolidWorks. So as many as you may know, this is a project that we do in Manufacturing Technology 1, Introduction to Woodworking class. So we are going to start out by drawing the top of the shelf, and you'll notice here that I put the origin in a certain location for all of these for a very good reason. So these are all different individual part files. So I'm going to pull this to my other screen, and in SolidWorks we're going to hit File, New, and we're going to start with a part file. Let's make sure that we are in IPS, so down in the bottom right hand corner, make sure you're in IPS. And the origin is located dead center on the top of this. And if you're thinking ahead, this is the top of the wall shelf, so it would make sense to draw it on the top plane. Okay, so I'm going to start out by getting the center rectangle, click right on my origin, and I'm going to draw out. That puts the origin dead center on the top. It's really easy to do it like that. Get your dimension tool, and the depth, which in this case is like the height of this picture, is 6, and the overall width is 32. Go to the Features tab and hit Extrude. And it doesn't matter if you go up or down, but if you're following the picture, the direction is down. And this is 3/4 of an inch thick, so 0.75. Okay, so we have the basic rectangle. Now we need to put that fancy edge that goes around 3 sides, and that would be done with a router if you are good at woodworking or know what I'm talking about for woodworking. So to do this, we actually have to do what is a swept cut or a sweep cut. So you can see up here some of the things that I wrote, tools that you're going to learn. Is using planes within your part to your advantage, mirroring, offset distance, swept cut or sweep cut, and collision detection. Okay, so the first thing we're going to be doing here is actually that sweep cut. But to do that, you need 2 things. You need a path and a profile. So let's first draw the path. So go on your Sketch tab, select Sketch, click on the very top of this, and if this is the back of the shelf, that's what goes up against the wall. So we want to keep that flat. So I'm going to get my line tool, and I'm just going to trace the 3 other sides. So right on the corners there. Hit Escape, and then return from your sketch. That's the button on the top right. Okay, so that is our path. We're going to come back to that later. Now right now it's still selected, so I'm just going to click out in this blank area so it deselects it. And I'm going to rotate around to the back, get my sketch tool again, and I'm going to click on the back of this. Now I'm going to zoom in over here on the right so that it matches our picture. And the first thing that we need to do is actually connect to this path. So what we're doing is trying to draw the profile down here that's going to get cut out. So to connect to the path, I actually need to get a construction line. So get your line tool, check the box that says for construction. Right here's my path. I'm just going to draw that down, and I'll hit Escape. So that right there is a construction line. Now that connects us to the path. Now we can do the rest of this. So I'm going to do this with my 3-point arc tool. Click right on the end of that construction line, somewhere down right about here. Okay. And while I have this tool, I'll go from the bottom and to the left of where I finished the last one. Hit Escape. Now we just need to fill in. So the line tool, you can connect the 2. The line tool, I'm going to go from the bottom of this arc over to the corner and back up. So this will not work unless you actually do these, because it needs to be a closed-in profile. So that's what most students forget to do. So I'm going to hit Escape, and now I just need to dimension a bunch of this. So before I dimension it and it kind of goes crazy on me, what you might want to do is make sure that you have this as a horizontal line. You might want to select both of these arcs and set them to equal. And their center points are all over the place. So I actually need this center point of the arc, holding Shift, and the horizontal line in the middle to be coincident. Okay, so that means it's straight across. Now we're going to do that same thing again for the other arc. So select the other center point, holding Shift, select the horizontal line, and coincident. When you do that, it should adjust this. Now you see it jumped mine really far off the screen. So with no tool selected, I'm just going to click and hold on a dot, kind of readjust this thing so it looks a little bit better. Okay. So now let's start to add some dimensions in. And you probably don't need all of the dimensions, but I'm going to start by adding this small one up here, which is 0.125. You can see it rounds there to 3 or to 2 decimal places. I'll change mine to 3. You don't have to do that. It's already 0.75 thick, so you don't need to change anything there. I am going to select this dot in the far right line to make that 0.75. I'll measure one of my arcs, so 0.3125, just so you can see how many decimal places. It is 4 decimal places, and that gives you a really good idea of what it looks like. So I'm going to hit escape and just figure out what's going on here. What am I missing? So this is all fully defined. Yours might not be. Mine just locked in. Basically, it made this center point coincident with the right edge of this. And the thing that I'm actually missing here is this arc, holding in shift, and the bottom of my piece need to be tangent so that it is a nice perfect curve. So that should fully define this. So again, we do have a line, even though it's hard to see, a line at the bottom here to the corner, and then up to this right here. And above it is a construction line. So just so you can see, I'll rotate to another angle. So as you can see, it is a closed-in shape. Now I'm going to hit return from sketch, up in the top right. And now we have a closed-in profile and a path. So let's go to our features tab and hit swept cut. And here it says, what is your profile? Mine is already selected because it's what I just did. And the path is going to be the line that we did on the top. And it's going to take that path, or it's going to take that profile and follow the path. And since we did 3 edges, notice it wraps the whole way around. So you can hit green check. And this is pretty cool. It cuts it out nice and neat, just like a machine would. Okay, so the last thing we need to do here is change the material. So I'm going to right click on material, hit edit material. And this is oak. So go all the way down to the wood folder. And since a lot of these are going to be oak, I think it's easy if you just right click on oak and you hit add to favorites. Okay, when you hit add to favorites, you can hit apply and close. And now, from now on, all your other parts, you'll be able to just select oak right there. Okay, so this is the top. So let's save this. File, save as. And we can find our folder in TechDraw1. If you don't have a folder named Wall Shelf, just hit New Folder and name it Wall Shelf. And then this is going to be top. Okay, you can close that. Moving on, we have our right side, or our side piece. So we're going to start a new part. And since this is the side piece, it's only makes sense to actually draw it on the side plane. So we're going to draw on the right plane. Again, we are in IPS, so you can check that down there. And just use your line tool to kind of sketch from the left over to the origin and then down. And you might be saying, well, our front view doesn't really match what I just did here. I'm kind of looking at this one, okay? So this is set up correct. This is actually dimensioned and laid out correctly, but this is what I'm really going to be drawing over here. I gave you a nice screenshot of my actual drawing. So I started to the left, went to the origin, and went down. Okay, so now I can dimension that. Across the top is 4.75. And going down is going to be 8. And now we have that corner. So to do in between here, we are actually going to be using the spline tool. The spline tool is the top row, third one in. And there are a few clicks here. So I'm going to start there. I'm going to move down to this area. Another click down right about here. And then down to the corner. And it's going to ask if you want to continue. I don't, so I'm going to hit escape. And now we can dimension this. Now there are a lot of dimensions here. And the spline tool is rather annoying because even though it says it's fully defined, it actually is not. So there are a lot of dimensions here, so just kind of follow with me. I'll do the width first. So let's get our dimension tool, and we're going to go from the right line to this first little asterisk or dot. Bring that down, that's going to be 1 inch. From the right line to the next one, that is going to be 1.875. Again, I'm going to change the amount of decimal places it shows so you can see. I'm going to go from the right line to the third asterisk, and that's going to be 3.25. Okay, now I'm going to be going up. So it's from this bottom dot to the first asterisk, move over to the side. That's also 1 inch. Bottom dot to the next. 3.875. Again, I'll change the decimal places there so you can see. And the bottom up to the third asterisk. And that's going to be 4.875. So right now it says it's fully defined, but as you can see, this does not look like the picture. This is why the spline tool annoys me, because even though it's fully defined, I can still edit it. So there's a little note that points to this area, and it says vertical constraint. So I'm going to come up here and just click on this dot, and it gives me this little arm or leg, I don't even know what you'd call it, that hangs off. And on some screens, some computers, you click on this diamond and it allows you to change some things over here. But what I have found is if you click on that diamond first and then the dot, then the vertical constraint comes up. So we're going to make sure that this is vertical. So again, click on the point, the diamond, and then the end point, and set it to vertical. And I can still rearrange that. Okay, so we'll hit the green check. Now we're good. Let's go to extrude. And again, it doesn't really matter, but if you extrude to the right, that's fine. So that's going to be 0.75. And then just these two little edges here are rounded over. So we're going to get our fillet tool on the features tab, and they are rounded over by 0.25. Again, in actual woodworking, this would be done with a router bit. Green check. Okay. Now, why didn't we round the other two? Well, the top board goes here, so it needs to sit flat, and that goes up against the wall. So the material is oak. And then we can save this as the side piece. Just side. Okay, you can close out. And we're going to start a new part. The next part that we're going to be drawing is the back piece. And in the back piece here, you can see there's a top, front, right. There's a little zoomed in version up here of that bottom fancy edge. So you can see this is a detailed view. Then there's these odd looking lightning bolt lines. And there's a note up here that says that this does not mean it is broken. This is a way of shortening an object that has a continuous pattern so it fits on the page. So this is a break view. A break view allows you to enlarge the image as much as possible when you have something that just continues on and it's the same pattern. So you can see this is 24.5. Even though this says it's 4, they look very similar in size, the length here versus the height, but the measurements are much different. That's because this piece is long. So by breaking it, I could enlarge this image so you can see more detail over here. So the only other thing that may look odd here is this origin is just kind of floating. I should have a note on here, but this is basically just indicating that it is in the middle of this board. So the origin would be like right about there. And on this top corner. Okay, so I'm going to pull this over, and in SolidWorks we'll make a new part. And we're actually going to be sketching on the right plane. So I'm going to be using that right view picture that you can kind of see. I'm just going to get my line tool and start to sketch this out. So it goes down, back up on an angle. There's a little flat piece down here. And if you're good with the line tool, and if I've ever showed you this trick before, with the line tool you can actually wiggle back over that last dot and it will turn into a curve. So again, wiggle back over that last dot and you can go all the way back. Now what if you're not good enough to do that? I'll delete all this just so you can see. So if you only got to here, you could just hit escape. we can use our 3-point arc. Just click on this. Okay, and again, I'm just going to go from right up above that to right about there. Hit escape. Now get your line tool and connect in between. Okay, so that's more similar to how we did it before. Now, by doing it like this, though, this line right here is not vertical. Most of the time it's not. So let's select it, make it vertical. Let's make that line and the curve arc that it connects to tangent. So it's a smooth connection. Okay, and then we can start dimension a bunch of all the other stuff, and we'll come back to this. So get your dimension tool. It says it's 3/4 of an inch thick. 7.5. Okay, it says this cut to the back is 1/4 of an inch, so 0.25. It says this line is at a 45-degree angle, so we'll select the angle line, this straight line here, move down 45 degrees. Overall height, so from the top all the way down to the bottom, is 4. And don't worry about how this messes this up down here. We'll fix that. So from the bottom to this cutout, so just this line, it says it's 1.5625. Again, I'll change the amount of decimal places you see. Okay, up to this point right here from the bottom is 2.8125. I'll change the amount of decimal places you see. All right, so a lot of this is fully defined except for this bottom. So I'm going to hit escape, and the first thing that we need to fix up is this line. So yours might be black, mine is not. So if yours is black, it means that this line, holding in shift, and this line are already collinear with one another. Mine was not, so I'm going to set it to that. Okay, so these two lines need to be collinear. Now, this totally screwed up this part. So I'm just going to click on a dot, move some things around. I might even have to zoom in. Okay, just drag some stuff around. Okay. So now with this portion is where we're going to look at that detailed view. So that's this right here. And this is the exact same router bit or pattern that we used for the top. Okay. So just like we dimensioned the top board, we did this little piece first. That's 0.125. Changing my decimal so you can see it. We dimensioned an arc, and the arc was 0.3125. From this point here, that connection point where it's tangent to the bottom, that's going to be 0.75. I'm going to hit escape, and now I can do some relations to fix the rest of this. So I'm going to select both of the arcs, and I'll make them equal. And then the center point trick. So remember the center point of one of the arcs, holding in shift, and the line in the middle, we're going to make that coincident. Okay, the one up at the top, since it's already tangent, might already kind of be fixed, or it might be fully defined. If yours looks like mine, this center point and this bottom line also need to be coincident. And then I'll move it down. Okay, so you're just going to kind of work with this a little bit. Basically, yours is probably, if yours is still underdefined or blue, it's probably because your center lines, or your center points rather, are not straight across from here or straight across from the middle. So just kind of work at that. So now that should be fully defined. Go to Features tab and Extrude. And again, the origin is right in the middle. So we're going to change this from blind to midplane, and that total distance of 24.5. Change our material to oak, and we can save this as the back. Close out. Got one more part to make before the assembly, and that last part is called the back cleat. Okay, a cleat is a hanging device. So if you noticed on the back, we have this weird 45-degree cut. Well, here you have another 45-degree cut. So this board would actually get hung on the wall, and it's 19 inches apart because the studs, or the 2x4s in most homes, are 16 inches apart. So that gives me 1.5 inches from either side that I could put a screw in. I could hang the cleat on the wall, and then my shelf will actually just sit right on top of this. So I don't really have to put a screw or any attachment device to my shelf itself, just on this little piece. And this is normally just made out of like scrap wood. So all the rest was made out of oak. Just for a color difference here, I'm going to make this out of pine. Okay, so this is what we're going to be drawing. So start a new sketch on your right plane. And this is very simple to draw, so just get your line tool. Start at your origin. It goes up, and then down to the right on an angle, down, and then back to your origin. So make sure that these 3 lines are either horizontal or vertical. And then that this is 45 degrees. So with your dimension tool, click on the angled line and this vertical line it attaches to. Come down at an angle, and that's 45. The overall height of the left line is 1.375. 1.375. And the overall thickness of this is 0.25. A real easy part to draw. Feature tab, extrude, and we're going to be extruding to the right. And we're going to extrude this a total of 19 inches long. There we go. Okay, and then I'm going to edit my material, and we're not going to use oak this time. We're going to use pine, so go down to the wood and use pine. Apply and close, and we can save this as the back cleat. And then you can close out of that. So we are now ready to assemble. We finally have all of our parts drawn. So if I come over here and look at this, you can see that there are actually 2 side pieces, and they are all centered on here. As you can see, the parts are centered, and that back cleat obviously is centered too. But we are going to do something called a collision detection, and I'm going to explain a little bit more why that back cleat is made to that size that it is. So let's start a new assembly first. Make sure you're in inches, not that that's really going to matter. And it's going to ask you what you want to bring in. So we can just select all of them, hit open. And we'll just kind of place them where they go. So back cleat, side, and top up here. Okay. So because it comes in alphabetical, the back is the first one, and that one is fixed. I'm going to actually right-click on the back and make that float. And I'm going to right-click on the back cleat, and I'm going to fix that. Okay, so again, the back cleat is fixed now, and the backboard is floating. So this kind of just gets attached right there. So this is pretty easy. Go to get your mate tool, and we'll just click on the inside of this side piece, rotate around, and click here. It just attaches, green check, top to top, green check, and rotate around and do the back to the back. Now, this was really easy to bring these in and assemble these because we thought ahead and we drew on the correct planes. You may have to rotate these. You may have to go up to rotate component and rotate them around, so it was a little bit easier. But if you think ahead in the way that it's going to be assembled, you can draw on the correct plane so you don't have to rotate. And you can also use planes to your advantage, which you're going to see here shortly. So next, let's put our top on. So let's get the mate. Click right here on the top of the back. Rotate underneath to our top piece. Okay, green check. All right, now I'm going to rotate around to the back. So the back of the backboard and the back of the top. Okay, green check. Now, it's not centered. This thing can still slide left or right. So again, coming back to what I was saying, putting your origin in the correct spot and thinking ahead helps you save time. So what we're actually going to do here is mate the plane that goes through the middle of the top to the plane that goes through the middle of the back piece. So with this drop down visible, so if yours is not, hit the drop down. We're going to hit the drop down for the back piece, and you're going to find the plane that goes through the middle like that. So if you drew it like mine, this would be the right plane. hit the drop down for the top piece, and that also should be the right plane. So you not only can mate a side to a side, an edge to an edge, a side to a plane, you can also do planes to planes. Okay, so we have the right plane assembled, or the right plane of the back attached to the right plane of the top. Green check. Now that is perfectly centered. Now with that also being said, we can go up to drop down underneath linear component pattern and hit mirror components. And the plane that we want is going to be the right plane of the back or the right plane of the top, either one. And the component is going to be this side piece. And green check. Now what happens if you did not draw them like I did? Yes, you could hit insert component, bring in another side and assemble it with the mates. That's pretty easy. You could go up to reference geometry plane and actually make your own planes, but again, I'm trying to teach you how to think ahead. So now our shelf is all attached, but it's not on the cleat. So I'm going to rotate around, and I'm going to drag this kind of to where it goes. And again, as you can see, this little 45-degree angle in here, it's going to sit right on that. So I'm going to get my mate constraint. I'm going to click that angled surface, rotate around underneath, click the angled surface here, okay, green check, and then I'll do this back piece to this back piece, okay, and green check. So it can still slide left or right. That's good. Okay, I'm going to get out of my mate. Now, a couple things of why this is done this way. So you see there's a little bit of extra space. So in real life, that's so you have room to actually put your shelf on. It has to actually have enough room for that pointed piece, as you can see, that little point to get up in there. So there has to be a little bit of a gap. Okay, the other nice thing is, with all this excess space, you can attach this to your wall right where the studs are, and then you actually have room to slide your shelf to the left or to the right to center it up on your wall more where you want it to be. Okay, but here's the collision detection thing that I wanted to show you. If you go up to Move Component, and over on this left side you hit Collision Detection, you can have all components, and now when you drag the shelf, it will hit and stop, as you can see. Now if you do this fast enough, yes, you can glitch out the computer, but this is showing you how it actually collides with something else, and it realizes that and gives you a warning. So nothing special when it's just a shelf like this, but when you get into more complicated drawings, that is very useful to have. So that is the wall shelf. You can save this as the wall shelf assembly.